Part 3. So now this other kind of angle is called an inscribed angle. All right, so an angle whose vertex lies on the circle and whose sides of the angles are chords. So a vertex is on the circle and it's formed by two chords. And it's always going to look like this. All right? So get used to that. The visual identification piece is what causes kids problems, where they're going to get all these different kinds of angles mixed up. So really connect what an inscribed angle looks like. All right, here's the deal, right to the guts of it. If this inscribed angle is 40 degrees, then its intercepted arc is double. 40 makes this 80. 30 makes this 60. All right, 100 would make this 200. All right, so whatever this arc is, the angle is 1/2 of that. So I could say 1/2 x and x, or I could say, oh, if the angle's x, then this would be 2x. Or I could say it's in the ratio of 1 to 2, right? Depending on how the wording is. All right, so I know the pictures look funky, just bear with me. The first one is what I just explained. All right, if you have an inscribed angle, the measure of angle ABC, so this angle is going to equal 1/2 the arc. The arc's bigger. All right, sometimes kids get it mixed up and they make the angle double the arc instead of the other way. All right, the arc is double the angle's half the arc. All right, now this picture looks wild, right? Understand, from A to B, this is some arc. But look at angle C. If you can imagine only angle C here, all right? That's a chord, that's a chord. Well, that's inscribed. What's its intercepted arc? What portion of the circle is it eating? AB. Well, look at angle D, same thing. Intercepted arc, AB, all right? Inscribed angle. Same thing with E, with F, and with G. They all have the same intercepted arc. Well, since they have all the same intercepted arc, and each one is an inscribed angle, right? On the circle, 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 then all 5 of these angles would have to be congruent. All right, so since they all have the same intercepted arc, in this case AB, all 5 of those angles would be congruent. And then finally, an angle inscribed in a semicircle is a right angle. Well, what would we say? Inscribed angles are equal to 1/2 the measure of the intercepted arc. Well, what's the intercepted arc if we're dealing with a semicircle? If it's inscribed to a semicircle, we identified before that a semicircle's arc measurement is 180 degrees. So if this has to be half of 180, it's always going to be a right angle. So I could have put C over here. Boom, boom, boom. Still going to look like a perfect 90-degree angle, no matter where it is. All right, so those are the 3 relationships you need to know there. All right, this is my little ghetto additional sheet. 2 types of problems to consider. This is going to be on your Castle Learning assignment. All right, this picture is common. Angle C here, ACB or BCA, right? Any of those 3 names. C, ACB, or BCA. On the circle, on the circle, on the circle. Chord, chord. Oh, this is an inscribed angle. This X is an inscribed angle. This angle C. Oh, wait a second. Radius, radius. Oh, those 2 radii, that makes a central angle. So I got a central angle and an inscribed angle. And what are their intercepted arcs? Well, for the central angle, the intercepted arc, the portion of the arc that it's, the circle that it's eating, is arc AB. For the inscribed angle, ACB, oh, that's the same arc. So think about it. If I know the measure of the central angle and its arc are the same. So 84 makes this 84. Well, if this is 84, then what's the inscribed angle? Half the arc. If this is 84, this is 42. All right, and I can do it that way where I give you the central angle and ask you for the inscribed, or I can reverse it. Make believe I gave you this was 40. Oh, 40 would make this 80. If this was 80, this was 80. So it goes either way. The second kind of example is when you have an inscribed triangle. A triangle inscribed within a circle. My circle got a little messed up there, but I was losing patience, sorry. So, you better know, 1 angle, 2 angle, 3 angle of a triangle, of course, adds up to 180. I don't know why I'm making hand gestures while I do this, but whatever. All right, 1, 2, 3 adds up to 180. All the way around adds up to 360. All right, well, hold up. Chord, chord. Well, wait a second. All 3 sides of this triangle are chords, which makes 1, 2, 3. While there are 3 angles of the triangle, there are also all 3 inscribed angles. So this 80 is an inscribed angle, CAB. Its arc is here. If this is 80, this arc double 160. But here you go in the other order. If this is 120, it's the arc for what angle? Angle B. Angle B, chord, here's its intercepted arc. So if this is 120, this would be 60. All right, so wait a second. I got a 60-degree angle now, an 80-degree angle. I could add up and subtract from 180 and get this guy. 80 and 60 is 140. That leaves me with 40 degrees. So now I know this angle right here. Or you go the other way. We said this 80 made this arc 160. Well, now I got 160 plus 120. That's 280 from here to here, major arc. So what would be left? I subtract 360 minus 280, and I would have 80 degrees left over, and you'd be able to find this arc. So you might want to listen to that 1 or 2 times, maybe put the values in as I say it, and hopefully that helps. All right? Good luck with everything. If you need help, ask. I miss you guys so much. Talk to you soon.